Now here in this problem, a top of mass m equal to 0.5 kg whose axis is tilted by an angle 30 degree to vertical precesses due to gravity. So this is a problem on precision motion. Moment of inertia of the top relative to its symmetry axis is I. Angular velocity of rotation about that axis is 350 radian per second, and distance from the point of rest to the center of mass, center of inertia, is equal to L, small l. So let's draw the thing. So this is the axis about which precession happens, and this is ground, and here this is the top there. So this is the top, right? So this axis drawn here, this axis is which one? Axis of or the symmetry axis, as mentioned here, symmetry axis. Okay, and this is the vertical axis about which the precession happens, and the angular speed about the symmetric axis is omega. So this one is omega, and the center of inertia or the center of mass, this is the point at rest, so the distance is equal to L. So later on we'll put the values L, and this angle is 30 degree theta, and the precession of the top happens. That means this is the precession angular velocity, or omega p. Let's name it as omega p. So this is omega p is the angular velocity of precession. Okay, so this, and I about this axis, symmetry axis, moment of inertia MOI is equal to this capital I. Now we have to find the angular velocity of the precession of the top. So this is the point O, and what is the torque about point O? So that is the weight mg, and this is position vector r, r cross mg. That means about point O, torque on the top is tau equal to r mg sine theta. So it is r cross mg. So as this is the vector direction of r, vector mg, r cross mg, that is the direction of the torque vector is this way, cross, so into the plane of the paper. So tau equal to r mg sine theta. So tau is equal to r. So r is equal to L, right? So L mg times sine theta. So this is a problem on torque about a point, not torque about an axis, remember that. So the angular momentum vector of the top, see, so that is the angular, so as there, this is the precession of the top happening. So this is the angular momentum vector of the top, L, right? L equal to I omega, where omega is along this direction, this same direction as that of the axis, and the torque is this way, right? So what happens actually, What is torque? Torque is equal to dl by dt, right? Tau is equal to dl by dt. That implies dl is equal to tau multiplied by dt. So dl is the change in L, change in L in time dt. Okay. Now, so again here torque, the vector torque is perpendicular to L. So therefore, uh, as it is perpendicular, so its magnitude does not change. That means magnitude, that is L, is constant. Only its direction changes. Now let's see. At a certain time, this is L, vector L, right? And as the torque is there, so tau multiplied by dt is equal to dl. So this is dl vector. Dl vector is in this direction. So what does that mean? Let's make it up like this. Okay. So dl vector is along that direction. What does that mean? That see, this is point O. So with respect to point O, let's draw a cone. So the angular momentum vector traverses the slant surface of the cone. So this is L at a certain moment. That is the cone. So L at a certain moment, and after time dt, this vector is equal to L plus dl. So from triangle law, you know, this is dl, this is vector dl. So that is the center of the circle. So that is it. So from the top view, so from here we'll view the situation. So what do you see from the top view? See, this angle is theta, right? This semi angle of this cone is theta. So we'll calculate dl from here. So that's actually L sine theta. Now the magnitude remains same, L sine theta, this one, right? From the top view. So this is dl, magnitude of dl, and suppose this angle is d phi. So what about dl? dl is equal to L sine theta multiplied by d phi, right? So what is dl by dt? dl by dt is L sine theta times d phi by dt. What is d phi by dt? See, d phi by dt is nothing but, see, this is d phi in this diagram. This angle is d phi, and there this precision is happening at omega p. That's d phi, right? So what is d phi by dt? That is the precision angular velocity, omega p. So therefore dl by dt is equal to L sine theta into is omega p. So what is L? L is I omega into omega p multiplied by sine theta. This is because L is equal to I omega. So again we have calculated before that torque equal to dl by dt. So this was a vector, but its magnitude also we can write separately, tau equal to dl by dt. Now what was torque? If you recall that this was the top, and from point O the torque was, this was mg, that is theta, and this distance is L. So torque is equal to mg L sine theta is equal to dl dt. What did you find out from here? dl dt this is equal to torque equal to dl by dt. So dl by dt from here, right, is equal to L I omega. So L for I omega into sine theta. See here, right? I omega sine theta to omega p. So therefore mgl equal to I omega into omega p. So therefore the precision angular speed you can find out like this: mgl divided by I omega. So this will be the expression for the precision angular speed. So this was part A. So this is answer to part A. Now for answering part B, in part B you have to find magnitude of direction of the horizontal component of the reaction force acting on the top. So as this is the top, so there is a reaction force here which has got a vertical component and a horizontal component also. So this FH, let FH be horizontal component. Of reaction force. Acting on the top. So straight away Newton's law works for whatever situation it may be. So there this center of mass of the torque moves in a circular path. As this angle happens to be theta, so the radius of the circular path happens to be L times sine theta. So that so the center of mass has a centripetal acceleration AC. So we can write center of mass of top moves in a circular path of radius L sine theta. So its acceleration, so AC, so acceleration of center of mass. AC is in the direction shown towards so this is the center of the circle, right? Center of circular path of center of mass of top. Okay, so what is AC equal to? Radius times precision angular speed square. So the mass of the top m multiplied by this acceleration is equal to FH, the horizontal component of the reaction force, because all the other forces act like this, mg, and there is a FV, vertical force.